Hi, welcome to the Modulate collaboration session, Factoring. This collaboration session will be broken into two parts. Part 1 is a short video that you'll watch here. Please be sure to listen carefully to the video and take good notes. Please be sure also to stay all the way until the end of the video, as you'll be given a special password needed to proceed to Part 2 for this collaboration session. After you watch the video, you'll want to check your teacher's announcement page for the schedule of days and times that Part 2 will be offered. Your participation in Parts 1 and 2 will both be required to receive full credit for this collaboration. Today we're going to be talking about factoring. Let's first think about what we already know about factoring. We know that when we're factoring, we're trying to find how to use multiplication to create a trinomial. Which factors could be multiplied together to create a trinomial? Let's look at our first example here. I'll begin by using the distribution method. I'll multiply x times x, which gives me x squared. Next, I'll multiply x times -1, giving me -1x. Next, I'll multiply -3 times x, giving me -3x. And lastly, I'll multiply my last terms of each binomial, -3 times -1, giving +3. Now that I have my 4-term polynomial, my next step is to simplify by combining like terms. If you notice, the blue terms here, -1x and -3, are like terms because they have common variables. I can combine -1x and -3x to give -4x. So my final simplified trinomial is x squared minus 4x plus 3. Let's look at a second example. We'll use that distributive method again. X times x giving x squared, x times 1 giving 1x, -2 times x giving -2x, and -2 times 1 giving -2. Our next step is to simplify by combining like terms. I can combine 1x and -2x to give -1x. My final simplified trinomial here will be x squared minus 1x minus 2. Let's take a look at our questions down below. What do all products in the right-hand column begin with, and why is this so? Well, if you notice, the right-hand column trinomials all begin with an x squared, because our first step when using the distributive method was to multiply x times x. So all products here in the right column begin with an x squared because when you use the distribution method, you were going to multiply the first term of each binomial, in this case an x, and x times x gives me x squared. Our next question asks, what is the relationship between the middle term of each product trinomial and the constants in the corresponding pair of binomial factors? So what they're asking us here is, how do we get from this -3 and -1 to the -4? Well, if you notice, using our distributive method, we multiply -3 times x and x times -1, giving us -1x and -3. Those can be combined or added together to give -4x. So the coefficient of the middle term is the sum meaning addition, of the constants that appear in the binomials. So this -4 is the combination of -1 and -3. Our last question asks, what is the relationship between the last term of each product trinomial and the constants in the corresponding pair of binomial factors? Our last term in this first example was a +3, and we got that by multiplying -3 times -1, giving me a +3. So the last term of each product is the product means multiplication, of the constants that appear in the binomials. Now let's try an example. We're going to be doing the entire thing in reverse. If we were given the answer, or the product, here in this trinomial, we need to now find the factors. So first we're going to start with our parentheses. And what do we already know about the first term? Well, we know that the first term in each of those parentheses must be multiplied together to give me x squared. So I can go ahead and type an x in the beginning of each of these parentheses. Now our next step is to try to find two numbers that can be multiplied together and give me a positive 6. So let's make a list of those factors. I know that 1 and 6 could be multiplied together to give 6. I know that -1 and -6 would be multiplied together to give 6. 2 times 3 equals 6, and -2 times -3 also equals 6. Now we need to look at our list and decide which two of those could be added together and given a -5. If you guessed our last set here, -2 and -3, you are correct, because -2 and -3 would be combined to give -5. So my last step is just to simply write those factors into our sets of parentheses here. So the two factors to be multiplied together to produce the trinomial x squared minus 5x plus 6 would be x minus 2 times x minus 3. We'll use our distributive method here to double check and make sure that our answers are correct. We'll first multiply the first term of each binomial, x times x, giving me x squared. Now we'll multiply x times -3, which gives -3x. Now we're multiplying -2 times x, giving -2x. And lastly, we'll multiply our last terms, -2 times -3, giving positive 6. Our last step is to combine and simplify. If you notice, our two middle terms are like terms because they have the same variable. So we'll rewrite this using our same beginning term as x squared, combining our middle terms to -5x, and bringing down our last term of a positive 6. So our factoring here was correct. Now sometimes a problem may look a little bit different because it includes an extra variable, but our process will actually be exactly the same. First we'll look for a greatest common factor. In this case, there aren't any greatest common factors here. So we'll look at our parentheses, and we know that our first term needs to begin with an x squared. So we'll go ahead and type an x at the beginning of each of these parentheses. Now let's think about the last number. What two numbers could be multiplied together to give you a positive 12 and added together to give you a -7? If you guess -3 and -4, you are correct. So we're going to include those factors in our parentheses next. Now we're not quite done yet because we do have that extra variable to think about. What could I add to each set of parentheses here to ensure that we get a y squared at the end? We'll need to add a y to each set of parentheses here. So we'll add a y to that 3y, and we'll add a y to our -4 to make it a -4y. So our factors here are x minus 3y and x minus 4. We'll use our distribution method to double check our work. X times x gives x squared. X times -4y gives -4xy. -3y times x gives -3xy. And -3y times -4y will be multiplied to give positive 12y squared. Our last step is just to simplify and combine those like terms, which in this case are our middle terms. So we'll rewrite our x squared, combine our common terms in the middle, which would be -7xy, when we combine our -4xy and our -3xy, and then we'll keep our last term of 12y squared the same. So what happens when that leading coefficient is not a number 1? If you notice in this example, we have more than an x squared to begin with. Our first term is actually 4x squared. So we're going to follow these steps. First, we'll factor out the greatest common factor. In this case, there is no greatest common factor. So next we'll identify our A, B, and C terms. Our A, B, and C terms are simply the coefficients of each term of the trinomial. So our A term is 4, Our B term is 25, and our C term is 6. If you notice, I did not bring the variable down, just the coefficients. Step 3 is to multiply A times C. In this case, 4 times 6, giving us 24. Now we'll find the factors of 24. 1 times 24, 3 times 8, 2 times 12, and 4 times 6. Of our list, we're looking for the 2 that you could add together to give 25. Remember, 25 was our middle term of the trinomial. 1 times 24 equals 24, and 1 plus 24 will equal 25. So those are the factors that we'll use. Our next step is just to simply rewrite our original trinomial using the 2 factors we just found. We'll write the 4x squared exactly as it was, and we're going to break our middle term into 2 parts using the 2 factors we found, 24x and 1x. Our last term will remain the same. Now we'll factor by grouping. We're going to create 2 groups here. The first group, the first 2 terms, 4x squared plus 24x. All we'll do here is to try to find the greatest common factor. The greatest common factor of 4x squared and 24x is 4x. That is the largest term that can be divided into each of those evenly. Now we'll divide 4x into each of those terms. 4x squared divided by 4x will leave just simply x. We'll write that on the inside of our parentheses. 24x divided by 4x will leave 6. We'll write that on the inside of the parentheses as well, with the greatest common factor out front. We'll do the same thing for our second group, 1x plus 6. If you notice, the only greatest common factor that we can pull out here is a 1. So we're going to be sure to include that out front right here and write those same terms inside. If you notice, our binomials match. X plus 6 is included in each set of parentheses. So now we'll just simply rewrite. Our first set of parentheses here will include the greatest common factors from each, 4x plus 1. Our second set of parentheses, we will just rewrite that matching binomial of x plus 6. So our final factors are 4x plus 1 times x plus 6. In another example, you'll notice that in 10x squared plus 2x minus 8, there is a greatest common factor. So we will find that greatest common factor first, which is 2. Now divide each of the terms by our greatest common factor of 2, leaving us with 5x squared plus x minus 4. Our next step is to identify our a, b, and c. We're going to use the terms that are inside of the parentheses. So our a will be 5. Our b will be 1. Our x does not have a coefficient, so we're going to use a 1 in that place. And our c term will be negative 4. We have to remember to include the sign in front of the number if it's a negative. So our c term will be a negative 4. Our next step is to multiply a times c. In this case, 5 times negative 4, giving negative 20. We'll find all the factors of negative 20 in our list below. We'll look for the 2 factors that you could then combine to give a positive 1, because that was our middle term. Of the factors listed here, negative 4 and 5 are the 2 that could be combined to give 1. So we'll rewrite our trinomial with 4 terms using those 2 factors. 5x squared will be written exactly the same. Our x is going to become 2 terms, the negative 4x squared and the positive 5x. Our negative 4 will remain the same. Now we'll factor by grouping, splitting into 2 parts. Our first group, 5x squared minus 4. The greatest common factor here is x, so we will pull that out front and write the remaining terms inside. When 5x squared is divided by x, we're left with 5x. And when 4x is divided by x, we're left with just negative 4. For our second set, 5x minus 4, no greatest common factor here, so we're going to use the number 1 again. And if you notice, our binomials once again match. Since our binomials match, we can just simply rewrite. We'll include our greatest common factors from each group in the first set of parentheses, and we'll rewrite that common binomial into the second set of parentheses. We also have to be careful to remember to bring that greatest common factor with us that we found in the very beginning. Thank you for listening carefully and taking notes on this video on the steps for factoring. Your next step to find Part 2 for this collaboration session will be to check your teacher's announcement page by clicking on the green Live Lesson box, and then to find the schedule of days and times that Part 2 for this collaboration session on factoring will be offered. Please be sure to bring your notes and be ready to collaborate. As a reminder, you do need to participate in Parts 1 and 2 of this collaboration session in order to receive credit. You will need to give the teacher who is facilitating Part 2 a password to let him or her know that you have watched the video. The password you'll need to give that teacher is Math is Radical. Please be sure to record that in your notes so you have it ready to give the teacher when you attend Part 2. Thanks so much, and we look forward to seeing you in Part 2 of this collaboration session.